2016. So question number 3 is to do with vector spaces and subspaces. In question B, we need to find coordinates of a vector with respect to an R basis. So 3 part A, part 1, we have this subset W1. As you can see, it's a 2 by 2 matrix such that A11 plus 3A12 minus A22 is 0. Now, firstly, we can show that W1 is non-empty, and this is the first step you should always take. So W1 is non-empty, as for example, this vector here, 1, 1, minus 1, 4 belongs to W1. And that's because the element from row 1, column 1, plus 3 times the element from row 1, column 2, so 1 plus 3, take away the element in row 2, column 2, which is 4, that does give you 0. So you can see that this vector does belong to this subset. Now we take 2 general vectors in this subset. And you can see that from this equation, you can see that the element in row 2, column 2 should equal A11 plus 3A12. So here we take 2 general vectors where the element in row 2, column 2 is equal to the element in row 1, column 1 plus 3 times the element from row 1, column 2. And you can see that that is true for both of these vectors. And we take a general real number alpha belonging to reals. Then alpha u plus v, so we just use matrix algebra, and alpha u plus v gives us this new matrix. And here you can see that the element in row 2, column 2 is equal to the element in row 1, column 1 plus 3 times the element in row 1, column 2. So therefore this matrix also belongs to W1. So therefore W1 is a non-empty subspace of M2R. Now we come on to W2. W2 is another subset where A11 minus A22 gives you 1. So again, we can show that this is non-empty. So for example, here we have a vector 1, 1, minus 1, 0, which does belong to W2 because this element 1 take away this element does give us 1. So here we have a vector which is in W2. But you can see if we multiply this vector by 2, by the scalar 2, then 2u gives us 2, 2, minus 2, 0. And now this vector no longer belongs to W2 because A11 take away A22 no longer gives us 1. So therefore this vector 2u does not belong to W2. So therefore W2 is not a subspace. W3 is also not a subspace. So W3 is defined by the subset where the modulus of A11 minus the modulus of A22 is 0. So here again we can see the vector u here does belong to W3 and this vector v also belongs to W3. But you can see if we multiply these if we add these two vectors together, u plus v, then u plus v gives us this matrix 3, 1, minus 1, 3. And now you can see that the modulus of A11 is 3 and the modulus of A22 is 1. So the modulus of this, take away the modulus of this, is no longer 0. So this vector does not belong to W3. So therefore W3 is not a subspace of M2R. Now for part B, we want to determine the coordinates of this 2 by 2 matrix with respect to this basis, which means we want to write this 2 by 2 matrix in terms of these bases elements. So we want to write this matrix as equal to A times the first plus B times the second, etc. And this gives us 4 simultaneous equations. So for example, the element in row 1, column 1 on the left should equal the element in row 1, column 1 on the right. So we have 1 is equal to A plus a B plus no C's plus no D's. And similarly, we can do the same for row 1, column 2, row 2, column 1, and row 2, column 2. So we have these simultaneous equations. And we solve these simultaneous equations for A, B, C, and D. So I'll let you try to do that. And here is the solution. So A is 5 over 2, B is minus 3 over 2, C is minus 7 over 2, D is minus half. And these are the coordinates of this vector with respect to these bases elements. And that concludes the solutions for question number 3.